Alright, what's going on, guys? This is technically my second recording of this video. The first one didn't have good quality. I forgot to zoom in again. So I'm just going to do it again, but I'm not going to code with you guys this one time. I'm just going to, go over the code I've already written in the other video, but I'm just going to keep them both up. But yeah, the quality in the other one will be terrible. So let's go over what we're doing today. So we're going to do multi-object builder pattern and builder patterns. So I just wanted to quickly go over what a builder pattern is and when we can use a builder pattern to begin with. So here I've created two examples. One of them is a good example. Basically, this is a good candidate for it's a good class to be used with a builder pattern. And then there's a builder class for this class. And then there's a bad example, and I'll explain why that one is a bad example. But let's quickly start with the good example and why it's a good example. So the main benefit of the builder pattern is that when you have a class that has like a constructor or dependency list in a way that is like basically this. You see there's 6 dependencies here, 6 variables that are being injected into the good example class via the constructor. Technically, if you look at the code here inside the constructor, you see that you don't need to inject any one of them, right? These object dependencies can be null, and the boolean flags by default are false. So unless you want to set anything particularly, you don't need to send anything at all in the constructor. But that's not how constructors work. And I'm not going to create a constructor for every single one of my needs. So there's one constructor and that accepts all dependencies, whether they're null or not. This is exactly why it's a good candidate for a builder pattern, because instead of having to use a constructor all the time, I can basically use a builder and I set the dependencies I want to set and leave the rest alone. So I created a builder basically for this class, and here it is. You basically set all the flags, you can set the object dependencies, and at the end you call build, and then you get an object. So here's an example of that code. The painful method here is using constructor. What I do here is I only want to set flag 2, dependency 1, and dependency 3. As you can see, flag 1 is false, flag 3 is, also, I want to set flag 2. Let's actually set this to false also. Alright, so I only want to set flag 2, dependency 1, and dependency 3. So the rest is either false or null. This is what it would look like using the builder pattern. I would only set flag 2 to true, dependency 1 to the new object, and then dependency 3 to the new object or any other object that I want to pass in. Here you can see that I'm only using 3 methods to set those 3 dependencies. But here, using the actual constructor, I would still have to pass a value for every single one of the dependencies. So using this example, it may not be too apparent that this is actually the builder pattern is superior in terms of the amount of code that it requires to write. But imagine there being 8 or even more dependencies here in the constructor. Then you will still need to set them to null or false, regardless of your needs. But using a builder pattern, I don't really care how many other objects that the constructor may require. I'm only setting these 3. Because all the other things, all the other dependencies, related stuff, is being handled here. You're not avoiding using a constructor. Obviously, the builder still uses the constructor, but what's exposed to the developer through the builder is basically a much simpler API. So let's look at the bad example and see why it's a bad example. Here, I created a bad example class. So the bad example class has a card class, which I've also created here. It's a very simple class. It only has a string value and a method. The method is basically a setter for the string value, which is full name. So the card basically has a method to set the full name and then holds an instance to it, and that's it. And what the bad example class does is that it accepts a first name, a last name, and a card object, holds it into the card object, but it also sets a full name on the card object using the first and the last names that it receives from the constructor. As you can see, the full name is first name, space, and the last name here. So why is it a bad example? Well, because you need a card object. As you can see, my constructor assumes that the card object is not null. So it's not going to do a null check around it. It needs, not doing a null check is perfectly valid. You don't need to null check every single one of your stuff, your variables. It's okay to expect an object to be not null. But what if you don't want your object to function without a no value? This could be the case. So basically, your card object is a direct required dependency of this class. And then there's also the first name and the last name. These are also direct dependencies, but you don't hold instances of them, but you just pass it on to the card class. But that doesn't matter, right? Because as long as your card class, unless your card class exists, you will still have a null pointer exception here when you call this method on the card class. And this is exactly why this is a bad example. So let's look at the builder I created around it, right? I have a method that says the first name, another method that says the last name, and then a set card class, and then a set card method, and then a build method. Let's look at the use case for it. So what if I use this bad example builder like this? I'm the developer. This is an API that's exposed to me. I'm setting my first name, the last name. Since it's exposed via a builder pattern, if there's a method that's independent of any other variable, it is assumed that that method is optional. If you have to have the developer use that method, then it should not be a part of the builder pattern. So there's other patterns around it that forces the developer to basically use that. But I'm not going to cover that here. Basically, this is bad API because of how bad example class is designed. And here, if you look at this code, I'm setting the first name and the last name and not the card object. This is going to throw in a null pointer exception. Because the card object is not an optional dependency, like all these dependencies are for a good example. These are all optional. I don't need to pass them in because if I don't pass them in, there's a null check around them. And if they are null, they're still being initialized. And if I don't pass anything for the Boolean values, Booleans are always false, which is expected behavior. So, like I said, they're all optional. Not in this case. This is not optional. And that's why it's a bad example. I hope it makes sense that you don't really use builder pattern for, it's not a replacement for constructors. It's not a replacement for static creators. It's just, actually it's designed to make your code less verbose and more succinct. Okay, so let's move on to what I actually wanted to talk about today, which is multi-object builder pattern. So what are some use cases for it? Let's say you have a base class, and then you have two other classes that extend from it. And then you want a builder that creates either class A that extends from your class or class B that extends from your class, your parent class. So how do we achieve that? Well, so let's create our classes first, which I've already done here for another video. Our base class will be the vehicle class, which is an abstract class that has a string variable called make, another string variable for model, and another string variable for year. It also has a protected constructor. So ignore everything else for now. We'll get there. And let's just focus on these first. The most basic functions of this class. The variables that it holds and a constructor. And then the other class that I have is a car class, which again, the car class extends the vehicle. But on top of the functionalities that come with the vehicle, it also has a Boolean flag for whether it's automatic or not, called isAutomatic, and an enum field for fuel type. So it has its own constructor that accepts everything, including all the things that the vehicle accepts, plus the Boolean flag for whether it's automatic or not, and a fuel type. Let's look at the SUV class. Again, it's very similar. The only other thing is it has is four-wheel drive flag and a size flag for whether it's a medium or large size SUV. Alright, so there's more. There's also a constructor here, and there is So let's go over all the other things that we see here. There's an interface here called SUV Builder. It has basically two methods, so we can set these two particular variables, and then it has a build SUV method that basically builds the SUV and returns. But this is an interface, so we're gonna go over its implementation and where that implementation happens. So let's look at the car class. It has the exact same thing here, but except it's for the car itself. It has a car builder interface, which accepts the generic type, and then all these methods, all these setter methods for each variable, actual returns, they all return that generic type that's being passed in. And again, a build car method, so the car object actually can be built. So let's go back to our vehicle, which is the parent class. The parent class also has an interface in the exact same way called base vehicle builder. Again, there's a generic type that each setter method returns, but no build method this time. And why? Because I mean, it would be pointless, right? With this abstract class, you can never instantiate an abstract class on its own. So let's move on. What is this? So we have two. This is the most important part. We have two unique interfaces. I call them iCar Builder, which basically extends the car builder interface that we created in our car here, and the base vehicle builder we created right here. But for the generic type, we send in the classes itself, and then for base vehicle builder generic type, we send in the vehicle builder class, which is down here. And we do the exact same thing for ISUV builder, which is an interface I've created here that extends the builder class, the builder interface that I've created here in my SUV class, and also the base vehicle builder class that I've created here, and generic types required for these interfaces. Well, one of them is, again, itself, kind of cyclic dependency here. Well, not really. It just uses itself. And then a base vehicle builder interface and a vehicle builder class. Okay, so let's move on. So our actual builder is this one, a vehicle builder class. It implements the base vehicle builder, which is right here, and each one of these two. Okay, and if you look at the values here, you can see. So what happens here? Now we have our main builder that implements a base vehicle builder, meaning it has methods that you can use to set all the basics of the vehicle abstract class. It also has two interfaces for each one of our object types that extend the car or the SUV, that extend the vehicle class to create car or SUV. These two basically have the unique fields for each of those types. Like you see here is automatic set fuel type. For SUV, it's set is 4-wheel drive and set size. And then obviously the build methods right here. So you also have all the fields that we need here, like you would in any other builder. But why is it so unique? Because it allows you to, first of all, I'm not sure if you noticed, but they both extend the same one here, and this one does also. So those methods actually collide. What happens here is you don't need to implement them for each and every one of them because their type arrays patterns are basically identical. So you basically implement them once, and then they basically handle the interface requirement for both iCar Builder and iSUV Builder. So as long as you're setting values for these, as you can see, the return type is still a vehicle builder, which is this one. But the moment you set a unique value for your vehicle types, meaning the moment you either use set fuel type or set is 4-wheel drive, the return types change. And because the return types change, you no longer can go back to creating a if you basically start setting the fuel type, you can no longer go back to setting any variable for the SUV. And if you're setting this is 4-wheel drive flag, you can no longer go back to car builder type. So this one builder here allows you to build both types, and it's perfectly aligned. It perfectly aligns with the requirements of each one of them, because the moment you branch off in one path, you can no longer go back, and you have to stick with your path until you get to the very end. You call it build method, and you get your object. Now let's look at the API. I mean, this is the API. Let's look at how this API looks in the actual code. Let's go back to our main class here. I'm not sure if, I hope it's close enough for you to see. Yeah, let's go back to the main class. All right, so I had them written here, but I commented them out, so we'll comment them back in. So let's see. Let's delete these. Right. So I have a vehicle builder. Dot. So these are the methods that are available to me, right? I can either set the fuel type, 4-wheel drive flag is automatic flag, or the generic flags that, generic strings for all vehicles. So let's start off with those. You don't necessarily need to start off with those. Let's start off with setting the make. Mercedes. Okay. I still have, same methods are still available to me. Why is that? Because I still haven't picked a path. Any class, any vehicle type can have a make field. So there's nothing generic to it. There's nothing unique to a car type just yet. But watch, I'm setting fuel type now. Whoops. To gas. Look at all the methods that are available to me. I can either go back to the generic type, generic fields, or I can set fuel type again, or use automatic. So, sorry, I got cut off. So, like I said, so after I set these flags, as you can see, I can no longer go back to the SUV type because I set those unique flags for my car. So I have to either build it. I can still add some car stuff here, but if you only have 2 methods, so it's, unless your use case is different, you can have more methods here, but I'm pretty much done. So I want to just build my car at this point. Build car. That's it. I can do the exact same thing for my SUV. Set the year, set the make the model. Is 4-wheel drive, set size. Perfect. This is a very safe API because, like I said, once you go down a certain path, you cannot go back. This actually can support more than 2. It doesn't have to be just 2 objects. You can add, you can apply this pattern to multiple objects that extend to the same parent class. So you should be fine. Let me know what you think about this pattern. I really like this pattern, especially when it comes to creating unique types like this one, car, SUV. Obviously, this is a very generic, basic use case no one probably has, but I've seen these examples in more complex code bases. I really like it myself, and let me know what you think. Thank you.